Topic 3-5, Part 1, Zero and Negative Exponents. In an earlier lesson, you learned how to divide expressions with the same base. You can use that property to examine and justify a special case. Simplify the expression 4 to the third divided by 4 to the third. Remember, when you have the same base like we do, 4, you subtract the exponents. So that's one way to look at it. Now, you can also look at it as 4 to the third means 4 times 4 times 4. And 4 to the third also means 4 times 4 times 4. And if you multiply 4 times 4, you get 16. 16 times 4 is 64. Divided by 4 times 4 is 16, times 4 is 64. And 64 divided by 64 is 1. So you can look at it as expanding out your powers. And you can also look at it, like I was saying, as subtract your exponents. Now remember, any number divided by itself gave me 1. So here, if you subtract your exponents, 3 minus 3, you get 4 to the 0. And that leads me to tell you that 4 being raised to the 0 power equals to 1. Because I worked the same problem, I just worked it 2 different ways. Here I expanded the powers. 4 times 4 times 4, 64. 4 times 4 times 4, 64. And any number divided by itself gives you 1. Reduce it on to 1. But we can also look at it the way we've been previously looking at it, is when you subtract exponents, when you're dividing. So 3 minus 3 gave you 0, but a number raised to the 0 power is 1. So that's something you need to memorize. A number raised to the 0 power is 1. A variable raised to the 0 power is 1. So let's look at the zero exponent property. The arithmetic form, -3 inside the parentheses raised to the 0 power is 1. Anytime you have values inside the parentheses, all of them being raised to this higher power of 0, you get 1. The algebra form, for every non-zero number, a raised to the 0 power is 1. For every non-zero number a raised to the 0 power is 1. So let's look at a few problems here. In topic 3-5, part 1. Simplifying expressions using the zero exponent property. Simplify each expression. Assume all variables do not equal to 0. So let's look at this first problem. We're dividing. Anytime you have terms in the numerator and terms in the denominator, you're dividing. So first thing I'll do is I'll divide 18 divided by 18. Well, if you divide 18 divided by 18, those reduce. We know they will eventually reduce to 1. Okay? So you can reduce those. 80 divides into 18 one time. 18 divides into 18 one time. X to the 20th divided by x to the 20th. We're dividing like bases. Subtract those exponents. Write your base down and subtract your exponents, starting with the one in the numerator, 20 minus 20. Well, x to the 20 minus 20 gives you x to the 0. There's no reason to put the 1 in front of x. Every variable has a number in front of it. It's understood to be a 1. You have a coefficient of 1 if you do not see a number. But x being raised to the 0 power gives you 1. So your final answer to that problem is x equals to 1. Let's look at the next problem. Example B. You have w to the 8th, z to the 15th, divided by w to the 8th, z to the 8th. You are dividing the terms in the numerator by the terms in the denominator. As long as you have like bases, you subtract exponents. So I'm going to write down my base w, and I'm going to subtract 8 minus 8. I'm going to write down my base z, and I'm going to subtract 15 minus 8. Well, 8 minus 8 gives you w to the 0. 15 minus 8 gives you z to the 7th. Now remember, any variable raised to the 0 power is 1. The variable is gone, the exponent is gone. W to the 0 is just 1. And 1 times z to the 7th gives you z to the 7th. That's your final answer, z to the 7th. Your next problem. 9, x to the 5th, y to the 12th, divided by 3, x squared, y to the 12th. So it's kind of like we're dividing 9 divided by 3, x to the 5th, divided by x squared, and we can make that one big division bar, and then y to the 12th divided by y to the 12th. 9 divided by 3 we reduce like a normal fraction. 3 divides into 3 one time, 3 divides into 9 3 times. 9 divided by 3 gives you 3. With exponents, we're subtracting. Like bases, 5 minus 2. With your y's, you're subtracting exponents because one's in the numerator, one's in the denominator. You are dividing 12. You're dividing, so you subtract 12 minus 12. So I keep the integer 3, subtract exponents. 5 minus 2 gives you x cubed. 12 minus 12 gives you y to the 0. We know y to the 0 is really 1. So you have 3 times x cubed times 1 equals 3x cubed. So your final answer in this problem is 3x cubed. I'll work that again. This is 3 times x cubed times y to the 0. Well, we know y to the 0 is 1, so therefore you have 3 times x cubed times 1 gives you 3x cubed. And our last example, D is 5 times x to the 0. Anytime you have a number and a letter side by side, that's multiplication. So this is 5 times x to the 0. Well, x to the 0 is 1. Therefore, you have 5 times 1. Therefore, your final answer in this problem is 5.